Hello friends, welcome to Sibanjit's live video classes. I am Ditishri and the subject that we are going to discuss today is quantitative aptitude. The topic of discussion will be number systems and we are going to discuss the third part of it, which is the remainder theorem and cyclicity. So before we move on to the main discussion of our topic, I'd like to request you all to please do like our videos and subscribe our channel. And there is also the discussion box which will help you out if you have any comments, queries or discussion. So without wasting much of the time, let's move on to the main discussion of our topic. Okay friends, now let's see what is this remainder theorem. So we have the question, find the remainder when 17 into 23 is divided by 12. Now normally what will we do? We'll first multiply this and then the answer we will be dividing it by 12, but it will be a very long process, right? So in this remainder theorem, what are the steps we have to do? Let's look at that. So we have the number 17 into 23 divided by 12. Okay, this is what the question is asking us to do. Now let's see how to solve it. In this remainder theorem, what we will do is that whatever side is in between, we will split that one and then we'll find the individual remainders and we'll do that following process. Okay, now you see first the number is 70. So we'll first divide 17 by 12 and in this case we'll find the remainder. So what is the remainder when we divide 17 by 12? It's 5. So we'll simply write here 5. Okay. Then we'll divide 23 by 12. Okay. So when we divide 23 by 12, the remainder that we get is 11. Okay. What is the sign in between both the numbers? Product. Okay. So we put a multiply sign and then we will solve it. What is the answer? 55. But you see this cannot be the remainder. Why? Because 55 is greater than 12. So when you get a number which is greater than this one, then what you have to do is you again have to divide this. So we have to divide 55 by 12 and the answer which we will get is here 7. Okay. So when we divide this answer 55 by 12, we get a remainder of 7 and this is the whole remainder of this entire sum. Okay. So finally our answer is we have a remainder of 7. Now let's see 23 plus 18. What is the remainder when we divide it by 10? So here we have 23 plus 18 divided by 10. So again we have to first take out the individual remainders. Okay. So 23 when divided by 10 gives us a remainder of 3 and 18 when divided by 10 gives us a remainder of 8. Okay. And what is the sign in between both the numbers? Plus. So we have to add them up, which gives us an 11. Right. Now you see 11 is again greater. What we have to do? We have to again divide this 11 by 10. So on dividing 11 by 10, we get a remainder of 1. So that means when we add 23 and 18 and divide it by 10, the final remainder will also be 1. So this is our answer. Okay, now let's look at some other types of sums. Let's solve the sum first one. We have 3 numbers, okay? This time we have 3 numbers. We have to add them up and then divide by 13. So we'll not do the complete addition, right? We'll follow the remainder theorem. So 81 when we divide by 13, what is the remainder? The remainder we get is 3. Okay. Next is 13 divided by 13. It leaves no remainder. So remainder 0. And next we have 20 divided by 13 leaves us a remainder of 7. So when we add them up, we get a remainder of 10. Now 10 is smaller than 13. So we did not have to divide it again. Okay, in the previous cases, the answer which we got was greater. That is why we divided it once again. But since 10 is smaller than 13, we did not divide it, and this will be your final remainder. So in this case, our final remainder will be 10. Now let's move on to this sum where we have 71 divided by 7 to the power of 10. Now, will you expand this whole sum, then take out the product and then divide? No. The shortcut we will use here is, we will have to write 71 isn't it? So when we expand this, we will get 71 10 times in the numerator and 10 times in the denominator also. So if we expand this, how it will be? 71 by 7, 71 by 7, 71 by 7 and so on. How many times will we get this? 10 times, okay? Just let me write here 10 times. Now you see, we will not multiply it and then divide. What we will do is that we will segment it and take out the individual remainders. Now when 71 is divided by 7, what is the remainder that you get? It's 1, right? Similarly, 71 by 7, again you will get a remainder of 1. So in this manner, we will get a 1 again up to 10 times, right? And what is the sign in between them? Multiplication. So we will have to multiply it all together, right? So 1, when you multiply it 10 times, what we will get? 1 to the power of 10, and which means it gives us a value of 1. Now 1 is again smaller than 7, right? So we did not have to divide it again, and this will be our final remainder, and our answer here to this case will be remainder is 1. So let's try out with these two sums, okay? So the first one here is 35 minus 12 minus 15 divided by 7. So let's start with this. So when we divide 35 by 7, what is the remainder? 0. 12 divided by 7 gives us a 5. Okay? And 15 divided by 7 gives us a remainder of 1. And what is the sign in between them? Minus. So we have to subtract them. So 0 minus 5 minus 1 gives us a remainder of minus 6. Now the question is that, what about this negative sign? Okay, we cannot have a negative number to be the remainder, right? But there must be some meaning to it, right? What is the meaning? So we'll pause this thing for a while and we'll try to understand behind this minus sign. Suppose I say, now here in this sum it was divided by 7. Okay, so now you see, suppose I take 10 things, 4, 5, 6, 7, 8, 9, 10. Okay, and then I tell you that divide these 10 things by 7. That means you have to make group of 7, right? So 1, 2, 3, 4, 5, 6, 7. These are the 7 things. So when you divide these 10 things by 7, means you make a group of 7. How many are left behind? 3, right? So 3 quantities, or you can say 3 terms are left, okay? Or you can say out of these 10 things, 7 has been grouped up and 3 is extra, right? So when they are extra means what? We have an additional of extra 3 items, right? That means when you divide 10 things by 7, you make a group of 7, 3 things are extra, okay? But now if I reverse you and ask that we have 3 things extra left, now to make another grouping of 7, how many things do we need? We will need 4 things, or you can say 4 items, okay? So now what happens, you see here, these 4 things, or you can say 4 items are lagging behind, right? With this 3 to make a group of 7. That means we are lagging 4 things, right? So this minus sign is indicating the same thing as this minus 4. Means we are lagging behind 4 units, or you can say 4 things with respect to this 3 to make a grouping of 7. So now in this case we are lagging behind by minus 6, right? So in this case, how many things will be extra? We will have plus 1, right? Plus 1 will be the extra thing, and if we add, or you can say 6, if 1 is extra, 6 is lagging behind. If we combine them, then it will make a group of 7, right? So in this case, the negative also you can tell to be a remainder, but still we consider the positive one, right? So when you divide this number by 7, we get a remainder of plus 1. Okay? Okay, now let's try to solve this sum. So let's take out the individual remainder first. So 16 when divided by 8 leaves a no remainder, so 0. Then minus 20 divided by 8 will leave a remainder of 4. Then again minus 2 divided by 8. Since 2 is smaller, it will leave a remainder of 2 only. Now when we solve this, we get a remainder of minus 6. So minus 6 means lagging behind. Okay, so to make a grouping of 8, what are the extra things we have? 2, right? So here 2 will be the extra things. We are lagging behind by minus 6 to make a group of 8, and so the remainder here will be plus 2. Okay friends, now let's try to understand the concept of unit digit. Okay, how do we find out a unit digit? So the first sum here is 238 plus 695. So now you see we are asked to find out the unit digit. Okay, so we must take into consideration only the unit digit. Okay, the other digits we are not concerned about that. Just you take into consideration the units digit. Okay, so now here the unit digit is 8 and here it is 5. So when you add both of them, 8 plus 5 will give us a 13, right? We are asked to find only the unit digit, so please be concerned about the unit digit only, and whatever digits are left, leave it aside. Okay, so as a whole, when we add these two numbers, what will be the unit digit? That will be 3. Okay, so moving on to this side, same thing we have to apply here is, we don't have to add it fully to find the unit digit, just we have to be concerned about the unit places. So here we have 0, 5 and 6. So 0 plus 5 plus 6 gives us 11, and here the unit digit is 1. So when we add all these three numbers, the unit digit which we will get is 1. Now let's see the case for subtraction. Okay, how do we find the unit digit when we have to subtract numbers? So same concept you have to apply is that be concerned only about the units digit number. So here we have 5 minus 7. So can we subtract 5 minus 7? No. So you have to borrow a number from this digit. Okay, after you borrow, whatever is there, we are not concerned. Okay, just borrow it. When you borrow the number, it turns out to be 15, right? Okay, so 15 after borrowing and then minus 7. So 15 minus 7 will give us an 8. So when you subtract this number, the digit that you will obtain in the unit place is 8. So let's see the case when you are asked to subtract a smaller number from a bigger one. Okay, now you see in this case 235 was greater than 177, but in this case 177 is lesser than 235. How do we find the unit place here? Now you see, be concerned only about the units digit place. So here we have 7 and 5. We can easily subtract, right? So 7 minus 5 will give us a 2. But is this the right answer? No. When you have a smaller number and subtracting with a greater one, then the first step which you have to do is just normally take the unit digit places and subtract them. Here 7 minus 5 is 2. Okay, but there is another step which you have to follow. This is, you have to take 10 and then you have to subtract the number which you have obtained, which is 2. And after doing this, we get an answer of 8, and this will be the remainder of this particular number. So when you have a smaller number minus a greater number, first normally find the difference between the unit digit places, then minus it from 10. So with this we get 10 minus 2 is equal to 8, which is the answer for this subtraction. Now let's try to find out the unit digit when we are asked to multiply two numbers or three numbers, you can say, okay, for the case of multiplication. Now you see, in this number 268 into 453, okay, we'll not take into consideration the other numbers. We will take only the unit digit numbers, which is 8 and 3. So 8 into 3 gives us what? 24. But as I have told, consider only the unit digit place. Others you leave aside. So in this case, what will be the unit digit? It will be 4. Okay. So moving on to this example, here also just consider the unit digits. Here we have 3, 3, 6 and 4. So 3 3s are 9, 9 6 are 54. Okay. So leave aside the 5, take into consideration only 4. 4 into 4 will be 16. Leave aside the other number, consider the unit digit, and our final answer will be 6. Okay. So just let me expand and tell you all. 3 into 3 is 9. 9 into 6 into 4, which will give us 54 into 4. Take the unit digit only, and then it will be 16. Okay. So here we have 6 as the unit digit. Okay friends, now let's try to find the unit digit of 2 to the power of 23. If you try to expand this number, it will be a very large number, right? And it is just not possible to find out 2 to the power 23. It will take a lot of time also. And we don't have any operations also in between, so that we can easily find the unit digit, right? So in such numbers, how do we find the unit digit? Here comes the concept of cyclicity. Now what is this concept of cyclicity? We'll try to understand that first. So if I say 2 to the power of 1 is how much? 2. Okay. Then 2 to the power of 2 will give us 4. 2 to the power of 3 will give us 8. 2 to the power of 4 will give us 16. 2 to the power of 5, 32. 2 to the power of 6, 64. Okay, and so on. It will keep on going. But have you noticed that 2 to the power of 1, 2, 2 to the power of 2, 4, 8, 6. They are all the unit digit here. See, 2, 4, 8 and 6. Now again, when the power is from 5, that is 2 to the power of 5, it gives us 32. Again the unit digit here is 2. 2 to the power 6 is 64. So what is the unit digit here? It is again 4. So here it is 2, here it is 4. Now the same cycle, this 2, 4, 8, 6 is repeating from here. See, 2, 4. If you continue, you will get 6 and 8. Right? So this cycle which is repeating after 4 steps is the cyclicity. Now for 2, we have the cyclicity of 4. Means after 4 cycles, the unit digits are again repeated. Okay. So for 2, we have the cyclicity of 4. Now let's come back to the sum. What is the unit digit for 2 to the power of 23? In such cases, the first step that we have to do is take the power, okay, and the base number, which is 2. Take the cyclicity of this. What is the cyclicity of 2? Which is now have got, that is 4. Now you have to divide this power by the cyclicity of this base number. Okay. So what we have to do, first step is 23, which is the power, divide by 4. Why 4? Because cyclicity of this base is 4. So when you divide 23 by 4, what is the remainder that you get? It is 3. Okay. 23 divided by 4 gives us a remainder of 3. Now next what? Next is that this remainder will tell us about the unit digit of this number. Okay, so now the unit digit will be the third term. Okay, third term of this cyclicity series. Okay, term of the cyclicity series. Clear? So what is the third term here now? 8. Correct? So hence the unit digit is 8. So whenever you have a number raised to the power of something, this is the process or the concept of cyclicity which you have to follow to find out the unit digit. Okay friends, now let's look at some of the other examples. The next one is 12 to the power of 50. So to find the unit digit of 12 to the power of 50, we will not expand this, right? Neither we will find the cyclicity for 12. Why? Because you see we are concerned only with the unit digit. So as I have told before, just consider the unit digit. So here we will not take the cyclicity of 12, but we will only consider the cyclicity of 2. Okay? So as I have explained here, 2's cyclicity is 4. So here what we have to do is power, okay, divided by cyclicity and check the remainder. Okay, remainder is 2. Now this remainder tells us about the unit digit. How? This remainder term. Now this is the remainder which is 2. So in this cyclicity series, which is the second term? 4. Okay, unit digit is itself 4. So what will be the unit digit here in 12 to the power of 50? It will be 4. Now moving on to this sum. 2 to the power of 129. How do we solve it? Now you see, the power has to be divided by the cyclicity, right? So in this case what we have to do, 129 divided by 4. Okay, but you see, will we divide the entire number by 4? No. Why? To check a number whether it is divisible by 4 or not, what do? We take into consideration only the last 2 digits. This was clearly explained in the divisibility part. Please do check that video. You can clear more of your concepts on divisibility if you go through the video. So we'll check out the last 2 digits. So when 29 is divided by 4, what is the remainder? The remainder is 1. Okay, if the remainder is 1, now which term we have to consider? The first term, right? And what is the first term? 2. So we have a unit digit is 2. Okay, so when we expand 2 to the power of 129, the unit digit which we will get is 2. Okay friends, now let's try to find out the unit digit for the numbers 3 to the power of 26 and 3 to the power of 52. For these numbers, we have to find the cyclicity for 3. So let's try to find out the cyclicity for 3. 3 to the power 1 will be 3. 3 to the power 2 will be 9. 3 to the power 3 will be 27. 3 to the power 4 will be 81. 3 to the power 5 will be 243 and so on. Okay. Now you see here also checking the unit digit places, we have seen that after the 4th cycle the digit is repeating. Okay, the unit digit is repeating. So hence 3 will also have a cyclicity of 4. Okay, so after we have found out the cyclicity, let's try to solve the sums. Now the first one here is 3 to the power of 26. So we'll take the power first, which is 26, divide by the cyclicity, which is 4. And what is the remainder? 2. Okay, we get a remainder of 2. Now which digit we have to consider? The second number, okay, in the cyclicity series. Now which is the second number in the cyclicity series? 9. 9 itself is in the units digit place, right? So we will be having unit digit is 9. Okay, so for 3 to the power of 26, the unit digit will be 9. Let's move on to 3 to the power of 52. So 3 to the power of 52, first step will be 52 divided by 4. Okay, so 52 when you divide by 4 leaves us a remainder of 0. So when you get a remainder of 0, now which term to consider? Always keep in mind that when you get a remainder of 0, consider that term which is equal to the cyclicity. Okay, cyclicity is 4, so consider the fourth term. Okay, and the fourth term is 81, right? And what is the unit digit of 81? 1. So the unit digit will be 1. Clear? Have a remainder 0. Please do keep in mind that in this case you have to consider the cyclicity term, and in this case we have a cyclicity of 4, so you have to consider the fourth term which is 81, right? And 81 has a unit digit of 1, so 3 to the power of 52 will have the unit digit 1. So friends, this was all about remainder theorem and cyclicity. I hope it was useful to you. So we are gonna continue with the later part of the videos on number system. So for that, please do like our videos and subscribe our channel. With this, I'd like to wind up today's session. I'll be back with another new topic for y'all. Till then, take care and goodbye.